Hello, we are the Wolf of WallTweet group, and this is our project presentation. So our background, our theory was that stock price movements are a function of sentiment, and the way we're going to measure system-wide market sentiment is through analyzing Twitter data and match that with firm-specific tweets and sentiment to firm-specific stocks. And so our goal is to, as I just said, use this Twitter data to predict the movements of individual stocks in the Dow Jones Industrial Average. So using those 30 firms, see the correlation between market-wide sentiment from Twitter and the stock performance over a year. And this is our project diagram. And at the core of it, we begin with the Vader API to measure the sentiment score of tweets that we take in from the Twitter API, and then later average that out to measure its performance correlated to the stock prices of the firms.
So some of the progress we made since our midterm presentation and reports. We began using the WallTweet 3 library on GitHub. This was in contrast to using Tweetbee to directly access the Twitter API. Basically, we needed a way to bypass the limit on the number of requests made, and WallTweet 3 allowed us to do this, as well as a way to access tweets that were older than just 7 days. So by using this library, we were able to get a bunch of old Twitter data, store the text of each tweet after cleaning and stripping the tweet, and then also store the date it occurred. We collected 10 tweets per day from April 27th, 2019 until April 27th, 2020. And this led us to basically accumulate this training data. So as you can see here on the right, we have the date of each, the date on the left, and then we have a closing stock price in the middle column. And then on the right, we have an average sentiment score of the tweets accumulated for that day. So this training data would be acquired for the S&P 500, and then there'd be a training data set for each stock in the Dow Jones Industrial Average as well. And this training data would then be fed into our LSTM machine learning model. That stands for long short-term memory. It was coded in Python using Keras. And one of the reasons we chose this is because through our research, we discovered that LSTM models basically be very strong with time series data. So as Horacio mentioned before, you can see in our diagram here that we, again, fed in dates, a sentiment score, and a closing stock price into this model. And now Blake will talk a bit about our results.
So the results for our model and as well as our data. So what you're looking at right now is our systematic sentiment that we received from Twitter. The blue line represents an average of systematic sentiment on each day. And systematic sentiment is the market-wide sentiment. And to capture this, we used the keyword or words relating to SPX, which is the S&P 500 ticker. So the blue line is the average sentiment on each day. And then the orange line is a 20-day moving average of this sentiment. You can see this sentiment remained above zero. So it was slightly positive throughout nearly the entire year. But you can also see that there was a dip in the average sentiment right around the time of the coronavirus. I'm actually surprised that it didn't go negative. This is a graph of the S&P 500. Down low is the S&P 500, or an ETF that tracks the S&P 500. And then above is that 20-day moving average sentiment. As you can see, the dip in the average sentiment, systematic sentiment, coincides with the dip in the market as a whole. And another interesting thing to note, sorry, can you go back, Bailey? Another interesting thing to note is that sentiment was fairly positive, and you can see the stock price throughout the year increased slowly. So that might be another thing to take away. This is how our model performed versus the actual. So the blue line is, excuse me, the orange line is the actual, and then the blue line is the results of our model. This is looking now, we've gone from market-wide sentiment now to Disney, firm-specific. So the blue line is the firm-specific sentiment for Disney, and then the black graph on the bottom is our Disney stock price, and you can see that the drop in the average sentiment again coincides with the drop in Disney stock price. Interestingly, though, Disney's sentiment, or Twitter sentiment centered around Disney, is negative throughout the year, which might be a reason to explain why Disney stock price stays fairly flat and doesn't increase very much at all throughout the year. If anything, it decreases. This is how our model performed against Disney. And then this is now looking at Apple. On the top, we have the sentiment for Apple. On the bottom, we have Apple's performance, stock price throughout the year. And an interesting thing to note is Apple's sentiment is positive, substantially positive throughout the year, and Apple's stock price increases throughout the year as well. And this is how our model performed against the actual stock price. This is a set of results for each ticker in the Dow Jones. For each ticker, we calculated the root mean squared error of our model that we trained. That tended to be around 7. And we also calculated the up-down % accuracy. So this was how many times our model, or the accuracy of our model, predicting that the stock price would go up when it did indeed go up, or predicting that the stock price would go down and the stock price indeed going down. So our accuracy was about 50%.
Some challenges as well as lessons we learned. One thing we did run into was a lack of Twitter and sentiment data for some specific stocks in the Dow Jones Industrial Average, such as Caterpillar. One of the reasons we believe for this was that when we made our Twitter API requests, we opted to only include the top tweets on Twitter in our search. This was done consciously because we didn't want to include random tweets that only had a few likes, and we wanted to include the top tweets on Twitter. But as a result, companies such as Caterpillar, again, might less frequently that are less frequently discussed. There might not be as much data for them compared to, say, Apple or Microsoft, which tend to be talked about more on Twitter. And another challenge was just the massive amount of data collection we had to do. We were limited again to just 10 tweets per day, but if we had more machines or higher computing power, we would have been able to collect more data. So in conclusion, as the graphs and our results showed, there does appear to be a positive correlation between Twitter sentiment and stock prices for those companies that are frequently discussed on Twitter. But again, as we know, predicting these fluctuations in the future is still quite challenging. And thank you. That was our project.
Thank you.